Assalamu alaikum viewers. Today I will discuss about deionization process or demineralization process. So before starting this deionization process, I will try to give short briefing about water treatment. So in our plant we are taking water from the river. Normally you know that river water is dirty water. In the water are available soluble gases, suspended solid, and another one is dissolved colloid solid. So these all impurities need to remove for using the river water. So first time we are removing this suspended solid by strainer, and after we are doing aeration system for removing the dirty. Okay, after removing this suspended solid, aeration system, and finally remaining this hardness, water hardness. That means in the water are present salt like this magnesium sulfate, calcium sulfate, sodium sulfate, calcium carbonate, magnesium silicate. These hardness are present in the water. For using this water, before need to remove hardness, because hardness is harmful for the boiler or for the plant. So we have to remove this water hardness like water salt. So in our plant we are removing hardness by resin. Normally two types of resin are available. One is called cation resin, another is called anion resin. Cation resin absorbs the cation and anion resin absorbs the anion. After absorbing all cation tower, cation resin absorb all cation, anion tower, anion resin absorb all anion. After absorbing all cation and anion, resin will be exhaust. So then required regeneration. So today I will try to give information how resin is exhausting, by taking cation and anion. So I will try to explain by diagram. So please watch this video up to last moment. So for demineralized water, demineralized means, you know, de means remove, mineralized mean mineral remove. So we have to remove mineral because this mineral are present cation and anion, positive and negative ion. These positive and negative ion are harmful for the boiler tubes or for the plant. That's why we have to demineralize this water. For demineralization this water, we are passing this water by the cation tower and anion tower. So how we are doing this process, I will try to give short briefing about this process. So you think this is the cation tower. You think this is the cation tower. So water coming from here. Okay. In this water present hardness like salt. Which types of salt? In this water possible to present calcium sulfate, calcium carbonate, sodium sulfate, magnesium chloride, like this. So in the water present this type of salt, calcium sulfate, calcium carbonate, sodium sulfate, magnesium chloride, like this salt are present. So this is positive ion and that is negative ion. So like this, calcium is positive ion, sulfate is negative ion. So this positive and negative ion, it is harmful for the plant. So we have to remove this cation and this anion. So first time we are taking this cation tower. In the water, like this hardness are available. With water, this hardness will enter on the top of the cation tower. So okay, Before time I told that types of resin are available. One is called cation resin, another is called anion resin. Cation resin represent as a R H plus ion, and anion resin represented as a ROH minus ion. You have to remember these 2 points. So this cation resin are available hydrogen ion. So cation resin, hydrogen ion are available when enter this hardness or this salt, that this salt are available which calcium ion plus sulfate ion, magnesium ion plus and chloride ion. These are available on this water. So this cation tower, normally it will absorb the cation, it will absorb the positive ion. Cation tower, this is called cation tower. Otherwise you call this as SAC. That means strong acid cation tower. Strong acid cation tower. So in this cation tower, when this product will enter, that time what will happen in this cation tower, resin will absorb the cation. If resin will absorb the cation, normally in this cation hydrogen ion are available. When it will absorb, that what will happen, you can see there in the cation tower R H plus ion are available. When calcium sulfate enter on the resin, what will happen? Calcium sulfate enter on the resin, what will happen? Which reaction will happen? You can see this calcium will react with this R, and this hydrogen will react this sulfate. That time what will happen? R calcium plus sulfuric acid, H2SO4. So if you balance this sheet, that time what is required? 2 RH plus ion, calcium sulfate, so R2 calcium ion and hydrogen 2 sulfuric acid. So like this reaction happen. So that means this resin, hydrogen will replace and calcium will absorb. Like this way, if it is react with magnesium chloride, what will happen? 2RH plus ion react with magnesium chloride, this one react with this, and this one react with this. So R2 magnesium ion plus hydrochloric acid. So there are 2 chloride, so 2 hydrogen. Okay. So like this way, this cation tower, cation resin will absorb the all cation. So remaining which one? You can see all cation absorbed during sulfuric acid, hydrochloric acid. Okay, if I give another reaction, RH plus calcium carbonate, what will react? R calcium plus carbonic acid. Okay, if you balance this, like this will happen. Normally you can think these 3 products are available in the water. Normally you can think another hardness also are available. So normally I will try to give explanation about these 3 salt, about these 3 I am telling again. So this water passing this side and enter on the cation tower. After entering cation tower are available cation resin. That means it is represented as a RH plus ion. So this cation tower main function to absorb the cation, absorb the positive ion and removing the negative ion. So this salt or hardness are available: calcium ion, magnesium ion, sodium ion. All positive ion will be absorbed on the cation tower. Remaining impurities or remaining what is called substance will remove from the cation tower and it will go to the degasifier. So remaining substance which product are available, these are exhaust cation tower, these are exhaust cation tower, and these also exhaust cation tower. So remaining which one? We can take two. These are exhaust cation towers. So remaining which one? Sulfuric acid. So from this cation tower will passes sulfuric acid. Okay. Another one, which one? Hydrochloric acid. Another one, carbonic acid. So these three products will passes from the cation tower. They are with water. So here are available carbonic acid. Carbon dioxide also harmful for the boiler tube or for the plant. So from this carbonic acid, we have to remove this carbon dioxide. These three, after removing these three, it will go to the degasifier. Degasifier like that. So this is degasifier tank. From this degasser, we are providing one pump. By this pump, we are providing air. So on this degasifier, we are providing air. We are providing air by the pump. If we provide air, this air break down carbonic acid. Go to the okay. So sulfuric acid, hydrochloric acid, carbonic acid, it will enter on the degasifier. Why are we using this air? Because we are using air for break down the carbonic acid. And break down, what will happen? It will create water and carbon dioxide. It will create water and carbon dioxide. That's why we are providing air on the degasifier. After breakdown, it will create carbon dioxide. This carbon dioxide and air removed by this way on the atmosphere, and this water will come down. Water will come down on the degasifier tank, and another impurities also come down on the degasifier tank. So the main function of the degasifier tank for removing the carbon dioxide by breaking down system. So after breaking down the carbon dioxide, remaining impurities, it will go to the anion tower. Removing the carbon dioxide. So from this degasifier, all impurities will go to the anion tower. All impurities will go to the anion tower. So you think anion tower like this anion tower, okay. On this anion tower, here are which impurities are available. Here available sulfuric acid, here available sulfuric acid, here available hydrochloric acid, silicate, sulfuric acid, hydrochloric acid, and the silicate are available. So this product with water, it will go to the anion tower. By this way, it will go to the anion tower. After entering anion tower, I told you this anion tower available anion resin. Anion resin is represented as a ROH minus ion. So R hydroxide. Our hydroxide is called anion tower. So on this anion tower, hydroxide ion are available. Hydroxide ion are available. So main function of the anion tower, absorb the negative ion and passes the pure water. Passes the water. How it will exhaust the negative ion? So on this anion tower are entire which product? Sulfuric acid, hydrochloric acid, and silicate. So in anion tower resin are available ROH minus ion. ROH minus ion. When it will react with sulfuric acid, what will happen? H2SO4. What will happen? You can see there. These are R positive, this positive, this negative. When react with sulfuric acid, this with hydroxide ion, and R react with sulfate. R react with sulfate. So what will happen? It will create R sulfate plus H2O. We balance this reaction. What will happen? R2 sulfate and this water create. Like this way, if ROH negative ion react with hydrochloric acid, then what will happen? R will react with chloride, R chloride plus H2O. So finally from this outlet we are getting pure water. We are getting pure water, and remaining impurities absorb on the anion tower. But from this anion tower also possible to small quantity of hardness possible to pass it. That's why this water will go to the MVP units. So in my next class I will try to explain about MVP unit. So for better understanding you have to watch next videos. I will give more information on next videos.